Ask most people to name the absolute fastest animal on land or in the water, and you will get two very confident answers. When scientists actually took modern instruments into the field to measure them, both of those widely accepted answers turned out to be completely wrong. The true numbers highlight a biological reality that rarely makes it into the record books. Moving through water and moving through air present entirely different physical challenges, governed by strict, uncompromising rules. Most of us assume these speed records are settled science, verified and locked away in a ledger somewhere. A huge share of these famous statistics actually trace back to estimates from the 1940s. People repeated these dramatic numbers for decades, largely because no one had the technology to properly double-check the math. The cheetah does hold the crown on land, but the universally cited top speed of 70 miles an hour is a fiction. Researchers at the Royal Veterinary College recently fitted wild cheetahs in Botswana with highly precise GPS and accelerometer collars to track their actual hunts. The fastest recorded speed peaked closer to 58 miles an hour, and even that was a rare burst, not a typical chase. The survival of the predator does not depend on moving in a straight, high-speed line. A cheetah succeeds by rapidly decelerating and changing direction, sometimes shedding half its speed in a single stride to match an escaping impala. By fixating on an artificially high top speed, we overlooked the biological mechanics, extreme braking and agility that actually allow the animal to eat. In the ocean, the sailfish held the undisputed title for decades, with encyclopedias repeating a swimming speed of around 68 miles an hour. That specific number originated in the 1940s from an incredibly crude calculation. Anglers hooked a fish and used a stopwatch to time how fast it stripped line off a fishing reel. That measurement includes the forward momentum of the boat, the pull of the ocean current, and the frantic jumping of a panicked animal fighting a hook. It does not measure a natural swimming speed. When marine biologists finally tagged free-swimming sailfish with modern accelerometers, the true hunting speed dropped to roughly 20 miles an hour. By measuring animals actively fighting for their lives, our understanding of marine locomotion was entirely skewed for nearly a century. Researchers later calculated the absolute biological limit of a fish's muscle contraction, establishing a firm speed ceiling of about 15 meters per second, or roughly 33 miles an hour. This shows a fluid dynamic principle called cavitation. At a critical velocity, water rushing over fins causes tiny, violent bubbles to form and instantly collapse. The sheer force of these implosions would literally shred the animal's fin tissue. This boundary is precisely why modern, rigorous measurements point to the bluefin tuna as the true fastest fish in the ocean. It cruises at exactly 33 miles an hour, right at the edge of the cavitation threshold. The ocean's speed limit isn't dictated by lacking muscle or failed evolution. It's a strict physical cap imposed by the water itself. Lining up the verified numbers, a 58-mile-an-hour cheetah versus a 33-mile-an-hour tuna, the land environment wins decisively. Water is roughly 800 times denser than air. Every thrust a marine animal makes forces it to push through a medium that resists movement like syrup. Out on the savanna, a running cheetah simply does not encounter an equivalent environmental wall capping the speed of its legs. The physical realities of an environment govern what biology can actually achieve. Dramatic, inflated statistics easily take hold in the public imagination, but they only survive until someone brings the right tools and measures reality.